undoubtedly kick up, settles down on the surface so it doesn't obscure the solar rays. One thing that's important to note, since we're communicating with Odyssey and MRO, they are passing overhead, so approximately 1 minute after touchdown, we'll start losing communication with the vehicle. So it won't be until an hour and a half after touchdown that we'll get confirmation of the solar ray deployment that you see here. As Ed mentioned, there were a lot of issues that we had to face on Phoenix. We've been working for the last 5 years on testing this vehicle. There were a number of recommendations, over 24 recommendations made by the various review boards for the Mars 98 failure, as well as a return to flight review that occurred for this O1 lander when it was set to launch along with Odyssey. We've addressed each of these. In addition to that, and I would suggest more importantly, we've addressed and found other areas of concern that could have caused the loss of Polar Lander. There are over 12 of which one could be extrapolated into 12 more that we have found. And so we feel we've adequately tested this vehicle. That being said, there are a lot of events. We fired 26 pyrotechnic events in the last 14 minutes of this vehicle, and each of those have to work perfectly for this mission to come off as we planned. We're very thankful for the landing site team to finding a site that's as benign as Ray and his team have come up with for us, and we're very hopeful for success on the 25th, and we're looking forward for your participation. And with that, I'll throw it back to Ed.
Ed, did you want to make any final comments before we open up for questions, or we're good to go?
I think we should go to questions.
Let's go. If you can wait for the mic and please give your name and affiliation before you pose your question. Gentleman here.
Hi, thanks. Mark Matthews with the Orlando Sentinel. First question for Ray and then another one for Barry. Ray, you're talking about the crater that kicked up all this fine soil. Do you have a sense of when that crater was formed? And then Barry, question for you. Just want to see, of the number of issues and potential problems, what would you characterize as perhaps the top 3 biggest worries you take into the 7 minutes of terror? Thanks.
The timing on the crater is uncertain because there are no small craters on top of the ejecta. The northern plains is mapped in a period of geologic time on Mars called Amazonian. So that's the last third of geologic time. So the crater is probably tens of millions of years, perhaps 100 million years, but the uncertainty is pretty high. Okay. It didn't form in the last century, though.
Okay, top 3 worries. I can't give you a top 3. I'll tell you, I will answer it a little bit differently. Hopefully this satisfies your question. My biggest worry is at the point in time that we separate from the cruise stage. We have a 3-second delay between separation from the cruise stage and we turn on our UHF radio and we start communicating with Odyssey and MRO. And the reason I say that is what's most important to me is that even in the untoward event that we fail, which is obviously a possibility, hopefully not a probability. The important thing to me is that we learn something from this, and getting EDL communication, which is something I didn't mention before, is something that Polar Lander did not have, and we implemented a very robust EDL comm program. Getting that communication down is the important, that'll be the 3 seconds that I'm really biting my nails over.
Any other questions here? Warren?
Warren Lee, New York Times. Question about communications. Is there any capability at all of this spacecraft communicating directly with Earth, or is it always a relay signal? And what does that mean in terms of reliability of your orbiters and how much data you have to transfer from one point to the other? And then there's a second question about the pulse landing engines. How is it different from the Viking engines? What's the different technology here?
Okay, I guess that question is for me. The first question, I'm sorry, I was thinking about the communication. The only direct-to-Earth capability we have is during EDL, we actually are recording the UHF signal. We're not getting telemetry out of it. We have no direct-to-Earth capability. From a reliability point of view on MER, Mars Exploration Rover, we demonstrated UHF communication with the relay orbiters with both landings for EDL as well as through operations. Most, if not, I won't even guess at what the percentage is, but most of the work that we do with Mars Exploration Rover is through the relay orbiters. We have a mission that can succeed in relaying with either of the 2 orbiters, Odyssey or Mars Reconnaissance Orbiter. And we also have an agreement with the European Space Agency that we could actually use Mars Express in an emergency situation. So we feel pretty robust with regard to the communications. Now, with regard to the thrusters, the difference between the engines on Viking and the engines that we have on Phoenix is on Viking they had throttled engines. So what they could do is they could vary the intensity of each of the engines dynamically. So they can increase the thrust level. What we do on Phoenix is we have thrusters that are smaller, but what we do is we vary the pulse time. They have fixed impulse, so we turn them on. They put out 68. Each of the 12 thrusters put out 68 pounds of force. We turn it on and off at 10 hertz. So we can vary the thrust and actually control the vehicle by dynamically changing the thrust. We're using more of a control system, active control system.
Any other questions here at headquarters before we go to the Johnson Space Center? One more, and then we'll go to the Johnson Space Center.
Dick Kerr, Science Magazine for Barry Goldstein. Could you carry the schedule out a little more after landing as to, say when the first picture would come down, first use of the arm and such?
Sure. Let me talk about it in a nominal sense, and then I'll talk about off-nominal situations, because it's very possible that this vehicle could be in an off-nominal situation on landing and still be healthy enough for us to recover. Right after landing, as I mentioned before, we lose communication with the vehicle about 60 seconds after touchdown. The first possible return of an image is approximately an hour and a half later. That would be on East Coast time, about 9:45 p.m. on the 25th, 6:45 on the West Coast. At that time, if the first images that the vehicle takes is those of the solar rays, clearly the most critical thing for us after touchdown is getting to what we call a power positive state, where more energy is flowing in from the solar rays than we're consuming, heating the vehicle and keeping the vehicle alive. So the first images we want to get down to the engineering team is the status of the arrays as they open. If everything works well with the arrays and they open accordingly, we take several more engineering images, not the least of which being an image of the landing legs, to see if the surface is actually as predicted and how deep we've actually penetrated into the surface and what the leg crush, we actually can crush the landing legs, what the leg crush is. So we'll get images of that sort. We also take other images of the other critical deployments that happen at touchdown, including the deployment of the meteorological mast, as well as opening of what we call the biobarrier, which protects the robotic arm during the cruise phase. So all those things should be available on the first downlink, which happens, as I said, about an hour and a half before touchdown. The next real opportunity for image downlink actually comes at 5 a.m. Pacific time the next day. All through the night, we have approximately every 2 hours, we have what we call health check passes with the various orbiters, but none of them are as high bandwidth as the two that we have every day. So first images of Mars, we have a fairly good confidence that we'll have 5 a.m. We'll be able to release approximately 11 a.m. Pacific time on Monday morning, if everything goes nominally. You asked about the robotic arm deployment, I believe, as well. According to the nominal plan, what we do is we actually wait till the robotic arm achieves a temperature that we feel comfortable with deploying it at, and according to the plan we have today, that would happen if everything goes according down the middle. That would happen on Tuesday, which would be the 27th. Okay.
Okay, let's go to the Johnson Space Center where we have a question and follow-up, and then we will proceed to the Jet Propulsion Lab. Go, JSC.
Thanks. It's Mark Carreau from the Houston Chronicle with first a historical question about Viking. Can you talk about how deep